Hello everyone, my name is Cerovic. I'm one of the organizers of this symposium. I'm an architect and a map maker. I've been making maps since I was a kid. It's been a passion of mine since ever. And in the last years, this passion has turned into a full-fledged activity. I'm doing a little bit less of architecture and a lot more of maps. Many kinds of maps, but those that are really kindest to me are transport network maps, be them underground or overground. So I would like to show you today 6 projects on 3 different levels or scales. The underground world, the overground world, and then move to a continental level. So let's start with the underground. I'll take Paris and Tokyo as examples. Why is the underground metro network so fascinating? It's a huge network, a huge infrastructure, decades of investments in building, hundreds of thousands of people involved in making them be and work, and yet it's completely hidden. It is underground. You cannot go through the tunnels and see them for themselves as you could do with the streets in a city. You can enter the system, but you cannot navigate it entirely. You can do it only inside the trains. So we have one world overground, the streets, the street level, the city. And we have a second world underground. And those 2 worlds function on a completely different dimension. Overground, if you need 15 minutes walking from point A to B, underground it may be 5 minutes by metro. Because underground you have no obstacles. It's a flat world with guaranteed, let's say, travel times, which are completely different from the ones above ground. So we have those 2 worlds which are parallel dimensions interconnected by the stations. The stations are portals through which you go from one dimension to another. Now, when you represent the above ground dimension, you might use a geographic map to represent the exact distances and the exact shapes of things. Well, underground, you don't really need it as such, because the distances are not the real ones. The time is distorted. It takes a lot less time to cross much vaster distances. So you are allowed to distort the real geography because that geography doesn't matter as your travel is concerned, because your travel is guaranteed inside underground tunnels. Hence, the schematic maps. They have other advantages, but basically they allow us to distort reality, real geography, to make the network, to fit the network itself. We are allowed to do it because we are in a completely parallel dimension, yet we have to keep the connections, because we have real connections, those portals, which are the stations. And then it leads to a kind of paradox, because we have that immense infrastructure, which is real, it exists. But for us as users, if we don't get a representation of it, it's virtual. It's not there, because you cannot see it all. You can see parts of it, but you can never see the whole picture. Only if you get a representation, a map, you can see the whole network in one place and understand how it works and how the different lines are connected. So the paradox is that the map, the artifact that represents something real, becomes the only reality. And the network which is physically real is absolutely virtual. Proof is, if on a metro map you just erase one station, it ceases to exist. It exists only for the people who stumble on it and see, oh, it's really there. But for all the other users, for all the other people who would navigate that network, it's inexistent. So the map is really the network. Now, how do you build a schematic map? There are many ways. I will show you how I have been building it. Of course, we're going to start with Paris. We're in Paris. It's one of the first I've made. And this is the official one from the RATP. the physical map of the network. I'm going to show you 4 lines as example, which are on that one, the north-south axis of the line 4, the east-west of the line 1, and the ring that is formed by lines 6 and 2. I use those lines just to illustrate the principles that are guiding the building of a schematic map. First of all, we want to simplify the shapes. You take line 4, it has some 12 or 13 kinks. It changes shape many times. Now, if you have a drawing that changes shapes many times, it's difficult to follow it, and it's even more difficult to memorize it. And we will have many lines, not only one on the map. So the more we simplify the shapes, the easier it will be to follow them and to memorize those shapes. It's very difficult to memorize more than 5 kinks. That's difficult to achieve in simplification, but we tend to go to as few kinks as possible. Second thing, topology. We are distorting geography, right? But we have to keep the meaning of things. If something is north of something else, it should be still up and not down of that one. If we distort too much, we lose the connection with the reality that is above ground, and then not only users can be confused, not knowing where they are exactly, but we are distorting too much the image of the city, because that map is one of the images of the city, and actually it has another very interesting property. It's one of the few things that we all have in common inside one metropolis. When there is one official map, one official metro map, everybody uses it. Nobody questions it. Everybody uses it, and it's the same for everybody. Rich, poor, using the metro every day or not. It's a common thing, one of the rare common things that we really have and we don't question. Example, line 1, that's the triumphal axis, the monumental axis of Paris, the Champs-Élysées. It's not horizontal, right? It's tilted some 22 degrees. And on a schematic, well, you are allowed to change those angles. But if monuments are aligned and stations that correspond to them, well, they should be aligned. If you break that line, it does not correspond to the perception of reality. It means you have broken the Champs-Élysées into several parts, which is not true. So you are losing that connection, and you are distorting too much the image of the city. Once you've managed to simplify enough and you kept the topology, you want to help even more the users recognize the city and help them memorize the network. So whenever possible, you will go look for symbolic shapes. Since, as I said already, we are allowed to distort things on a schematic map. Converting the lines 6 and 2 into a plain circle, well, it has the advantage of giving you more room, because it's the center of Paris where you have a lot of information, so it gives more room. But it's not like, oh, the circle is nice. No, those lines do have that function. They are orbital lines connecting all the others, and they are built on the emplacement of a former city wall, which was actually a circle closing the city. So it's not symbolic only for the aesthetics. It has to have a meaning too. It's not gratuitous. Now, when we have all those 3 approaches and we put them together, simplified lines, topology respected, and symbolics, we get the basic structure of the network. Now, it's very difficult to memorize an entire network with many lines. But if you have the basic 3, 4, 5, that you have them in your mind, then you can connect all the others to them, and you're not lost. You have a basic idea of how everything works. We apply it on Paris. Paris is a very complex network. It has lots of lines, but once you have that basic structure, which you will immediately recognize every time you see the map, you're not afraid to navigate that network. You have referential points. Now, the map as full. a lot of information. It's overwhelming. But you recognize those basic shapes, and then from them, you can go on if you are unfamiliar with the network. I'm not going into details here. I could talk for an hour about all the details of that map. Let's move to Tokyo. Now, Paris is complex, but Tokyo is more complex. Tokyo has many networks. There are 2 metro networks with different operators. There's a huge rail network by JR East. And then there's like a dozen smaller networks by private rail operators. Each one of them has its own map, its own color codes, its own signage system. They're all different. And there is no unified representation. Now, the challenge in such a big network is to unify everything into one single map that everybody can use and that is friendly to use. Because when you have all of this, I mean, I am scared. So how do we do that? We start from the basics. How does the city work? Tokyo was built around the castle, which is now the Imperial Palace. It's in the middle of the city. The city is built all around it, and you cannot cross the Imperial Palace grounds. So you might as well place it in the very center of the map. So it's clear where the center is. It's in the center of the layout itself. And then we add some landscape features. The Tokyo Bay, the sea, so that's the sea limit, and the rivers that limit the administrative boundary of the city. So you know, if you've crossed the river, okay, you're out. Or on the other side, you're in. With those basics, even if you have a very complex network, you know already where you are more or less. Now, the main lines and symbolic features, the Yamanote ring line is a line connecting all 6 rail stations in Tokyo. It's a ring line, it's one of the most used in the world. It does not have this shape exactly, but it's a loop line. So you want an easily recognizable shape that is balanced, that is symmetric. Because that will be the main feature that you recognize here, and you will use it all the time. Once you have it, you can add all the rail lines, because they mostly connect to those 6 stations. Here we are into information hierarchy. In the Paris example, we're talking only about the metro. Here we have different systems that function in different ways. The metro goes every 2 or 3 minutes, and it has a single line from end to end. Rail lines is different. They have timetables, they have different endings, they have branches. So you don't want to put all that information at once inside the map. You want layers of lecture. So I've placed all the rail network lines with pastel colors that are not the vivid, strong colors that you see first. Those come next. Here's one metro line, the Oedo loop line, another loop line, which defines the downtown. So it goes around the Imperial Palace, and if you're inside that, you're in downtown. If you're outside, you're not. It does not have in reality this symmetric shape. It's close to it. But since I'm allowed to distort geography, I'm looking for a shape that is easily recognizable and that makes you feel secure. Oh, it's balanced, it's symmetric, it goes around the palace everywhere the same. I feel safe inside this. And then when I have this base, I can add all the north-south lines for the metro, and then the east-west. It makes a lot of information. Now we have 2 levels, metro lines first, rail lines second, and then all the landscape information. When you add all the labels and numbers and all the information required on that map, it gets very busy, but you still recognize the shape of Yamanote, the shape of Oedo, and you know where you are, you know where to connect. You don't get lost inside the huge diagram. After doing Tokyo, I said, okay, now I can do everything. I'm confident enough to move further. So I started mapping other cities, and with each new city, I was changing the graphic language I used in the first ones. my idea was, could we use the same graphic language for all those cities? Same colors of lines, same stations, same everything, but without making uniform maps. Just a standard for graphic, but having each map being completely different aesthetically, in an iconic one for each. I reached 55, up to the 55 cities. Now that would be the basic graphic standards. You have a set of colors, vivid colors for metro and lighter colors for the second tier. We have the same icons everywhere. We have the same landscape features. We have a hierarchy of transport modes. So we represent in a different way metro, rail networks, light rail, trams. Okay, the differences are difficult to define, but I tried my best. And then you have all the composition rules. How do you use those graphic elements? So how do you intersect lines? How do you set them apart? How do you look for symmetry and rhythm inside the map? In the end, for each map, as I was saying, I don't want uniform maps. I just want you to, wherever you go, you feel safe because you recognize the same language that you master already. So even if you've never been to Tokyo, with a map that has the looks like the Parisian one, you go and explore. And each of those maps with those symbolic elements and structure, you can reduce it to a very simple shape, the iconic shape of that network. Over here, we have Tokyo. Two ring lines and the palace in the center. That's Paris. Have a circle, line 1, and the center. Now, this work, well, I had a lot of that, so what to do with it? You publish it, let the world use it. So I published a book when I had 40 maps ready, with the story for each map, explaining how it works and the whole standard. But before the book, I just made a website, published everything, and that's why this symposium exists, because then people saw what I'm doing, and after that I've been working with a lot of companies that are present here today. Then I made an app. It's a free app. People are using it around the world. I try to keep it updated. And recently, I started a collaboration with Google Maps, and now we are implementing those maps that you've seen inside the Google Maps app as schematic maps that come with the Google's platform. Let's move overground. Now it's a completely different story. We're talking buses and pedestrian scale, not you enter a train and you cannot alight before a station, before exiting the tunnel. No, here we are in the city. Luxembourg, the story of Luxembourg. Luxembourg used to have its historical map, and actually everybody was quite happy with it. As they say, nobody complained, so everybody's used to it. It does respect some rules of schematization, but it's a bit messy. Contrasts are not the best, and even though it's written center somewhere, it's difficult to identify parts of the city. You don't really know where you are, how it works. And there are just too many lines. You cannot follow them. They're crisscrossing each other. So when I discovered this map, I took it as a challenge, just to see, could we disentangle all this? Could we just put the lines in a different order, change the colors, group some of them, and started playing with that existing map. And while disentangling it, actually I realized the network is very well built, but very poorly represented. And it's a pity. And just redesigning this old map made no sense. At one point, no, that makes no sense. Let's make a new one. It's a good network. Let's make a good map for that network. So I designed a completely new map for that network. I'm going now into details how the process went. First, we start with geography. because now it's not metro. You cannot distort that much. You're on a pedestrian scale. From one station, you can see the next one. So you have to relate closely to the existing world. You're not underground. So we start from the existing network, and as usual in smaller networks, like in Luxembourg, we have a huge concentration of lines and information in the center, and then a very dilated network around. We cannot represent everything geographically. If you have a limited layout and a lot of information grouped in the center, that's important, and little information around. So the approach is to enhance the center and shrink the periphery so that we have a balanced distribution of information on the layout. Now in Luxembourg, it can work quite well because there are no many orbital lines, which are most distorted in that case. Now the symbolics. Luxembourg is a fortress. It's a fortress on a cliff. It has a pentagonal shape, roughly. It's a polygonal fortress. So just as with the Imperial Palace, I wanted that old part of town, which is what Luxembourg is known for, and banks, in the center. If it's the center, place it in the very center of the layout. Then you don't have to explain it's the center. It's there already. You intuitively know it. And from that pentagon came the structure of the map. Because the map is not a geographic map. It's a schematized geographic. It's a mix of both. So if you want to schematize and simplify, you might want to respect some angles, have a set number of angles that you will respect through the map, like 45 degrees in metro maps that is usually the standard. Now 45 degrees here, it doesn't work because it doesn't conform to the shape of the city itself. We have a lot of distortions if you wanted to fit streets that are not on 45 degrees into a 45 degrees structure. So in this case, I just looked at the city. How does it work? Well, we have the pentagon and we have avenues radiating from that pentagon. So you take your angles from the pentagon and you find an angle that can be multiplied, that is a fraction of the angle of the pentagon. Here it ended up being 18 degrees, which is quite convenient because when you multiply it, you get also to 90, so you get also the horizontal and the vertical. Now inside this central square, the geography is respected as far as the distances are concerned. You can use that part of the map as a walking map, as a sightseeing map. Outside, it's completely schematized and completely distorted. And then information hierarchy. Here again, we have a lot of lines. So what can we do not to overwhelm the user with so much information? So here I made two classes of lines. Those lines that use the central corridor, that's the main one between the train station and the center. They have vivid colors, and I grouped those lines if they share a common corridor. So when you're on the train station, you want to go north, plain north, well, whatever blue line you take will take you up north. That grouping works quite well in Luxembourg because, as I said, it's a very good network. So those lines really do share timetables too. So their frequencies add up. And then when they split up in the periphery, then the frequency is halved, so the width of the line is halved. So on that map, when you see a thick line, say, okay, that's a frequent line. I don't have to check the timetable. If it's a thin line, I better check the timetable because I might wait for 15 minutes or more at the station. A close-up of the central part of the map. You have the old town mapped as an old town with the buildings and the streets. Then you have all the streets around, the parks, the rivers, even some hints at the geography where there's a rail viaduct crossing the valley and the bus meandering and going up. And you see even the three-dimensional position and understand that, okay, there is a valley, there's something strange in here, I should investigate it, not just go and walk. This map is now the official map of Luxembourg. Because when I finished it and published it, and it had its own way through the US and back to Luxembourg, and people loved it, and then pressured the politicians, and then the politicians pressured the local transport agency, which was absolutely happy to have that pressure from the politicians, because it means they have no responsibility. The responsibility is switched to the politicians. So they say, oh, perfect, we want your map, come here. And ever since we've been working together and updating it, it's been 3 years now, and a new tram is implemented, and it has stood the test of time for now. The map works, the guidelines work perfectly. We had no trouble since then. Now, another overground. We move to Japan, Takamatsu. You knows the place. It's a small city, well, relatively small. It's way bigger than Luxembourg. It's like 1 million people on the island of Kyushu, facing the inland sea. So here on the panorama, you get an idea. It's a harbor city that's facing the sea with all those islands in the background, and on the other side you have the mountains. They have several networks inside. There's a bus network, that's the map up there, which is very difficult to use, and they agree that it's very, very difficult to use. There's a rail map, which is kind of cute, and they have those mascots, those dolphins that are everywhere. They're doing a fantastic work at promoting their small network, making it very friendly, and people love it. And they use also some old trains that are refurbished. They have their own mechanicians who are making new spare parts for all those trains. They just make them out of metal. Now, my idea was, again, like for Tokyo, to put all that together on one map, which was not the case in Luxembourg. I did show the rail lines, but did not focus on them. Now, what's the approach? We start with the cityscape itself, comparable to what I did in Luxembourg. In the center, we place the city center, and that part is geographically accurate. You have all the streets, so you can use that part as a walking map, because, well, when you are in that dense center where the network is very dense and stations are several hundred meters apart, you don't have to change buses. You can just walk from one place to another. It's not a metro network. You don't need transfers like that. And then the map is split into two. Up, we have the sea, which is very present in Takamatsu, and down there we have the valleys where all the buses go. Then on top of that we are the rail network. So it's a schematized, geographic schematized map in the center, and then purely schematized outside. Outside, the scale is not respected at all. On top of the rail lines, we had all the bus lines. I was lucky because they already had the color coding. All the lines that go to the west are blue, to the south are green, to the east are orange, and then some special lines have other colors. This map works. We have everything on it. It respects all the rules. It's quite easy to read, but still, although you see immediately the center of the city, it's quite difficult to understand all that's going on down there. Can I go from one line to another? Well, actually, you can't really, because those are river valleys, and each line follows a valley, and transversal connections are quite poor. So you want to give a feeling of that. So we add the valleys, put the mountains on. They are so present in that landscape that you really want to have them, and the mountains and the rivers. And, well, schematized mountains. Now it's starting to look really well. What can we add? Well, landmarks. Because it's a city that has lots of temples. There are like 100 temples on Kyushu, so you go from one to the other. Not exactly 100, a little bit less, but there's a fantastic park. And all those things, you want them on the map, so you can locate immediately where those things are. How do you get there? Which bus you use? So we'll add all of them on top of the mountains. And with the mountains, with the landscape, with the landmarks, just the final touch. The islands and the mountains on Honshu on the other side, and a perspective view, a bird's eye view on a schematic map that is flat. So you get all the benefits of the schematic map as a diagram, and you get the feeling of what this city is What does it look like? How people perceive it? I'm still trying to convince them to take the map. The tourist boat has taken it, and now I try to convince the transport agency to take the map and implement it. That was overground. Now we're going overground, but a bit wider. Still the same principles, but can we apply some of those principles on a continental scale? I'll start with the night trains. If you want to make a rail map, a rail map of Europe, showing all the tracks, okay, that's doable. But showing all the lines on a fixed layout, not dynamic, kind of impossible. You have so many different scales involved, so many thousands of lines that it just wouldn't fit. It would be immense. But night trains, well, that's another story. In Europe, there's like 150 lines for night trains. Well, that you can fit. It's like a bus map, basically. But night trains have a very particular way of functioning. It's not a train where you hop on, hop off whenever you want. No, it starts in the evening. It ends up somewhere in the morning. Usually, it doesn't stop on the way. So you need only the starting point and the ending point, basically. Okay, there are exceptions. So in that case, geography is not that relevant because you don't care where the train goes exactly. And outside it's dark. You cannot even see the landscape. So you're like in the metro. You enter, it moves, you get out. You don't really care where it goes exactly. Does it have kinks or not? So we can use schematic principles to map it. Here you have all the night train lines in Europe, all of them. People say night trains are dead. No, they're not. They still exist, and they're changing immensely. They used to be for workers, students, like cheap transportation mode. Now with the low-cost flights, they're not used for that anymore. Now they're being converted into luxury transportation mode. They are getting expensive because you go from center of the city to center of the city, no airport transfer, no queuing for security checks, complete privacy, nobody checks your luggage, and you get a good night's sleep and arrive fresh in the morning, especially with many lines in Germany and Austria, where you have your compartment with bathroom and shower. So you have a moving hotel room. You don't need to spend your money on the hotel. You start in the evening, get to your business meeting in the morning, finish your day, get back home, not stay in a hotel. Now, why a map of that? Why would you need a map of night trains? Because, well, you could just use a search engine for traveling and say, oh, I want to go from Paris to Berlin, how can I go? Well, first of all, it will not show you the night train first. It will show you all the possibility. You will be overwhelmed by all the ways you can go, and the night train will be lost in it. Second thing, the search engine will give you a perfect answer for how do I go from A to B, but it will not help you in, oh, I'd like to travel somewhere. If you don't have the question, you cannot get the answer with the search engine. The map does exactly the reverse. It shows you all the possible answers, so you can choose the question. So, for example, you say, I'm in Paris. I would like to go somewhere for the weekend, using a night train, not losing one day go and one day back with the planes. You get a spider map. You see, you don't have to ask the search engine, where can I go from Paris? No, you get it at a glance. You can go to south of France. You can go to Venice for a weekend. Very convenient. And you can go all the way to Moscow once a week. Okay, it takes 2 nights. But it exists. You can use that one to go to Berlin. In one night, you're from Paris into Berlin. Now, this is if you're from Paris and you want to go somewhere. Or the possibility, you say, I live in Austria. I don't want to use foreign trains. I want only ÖBB trains. What is their network? Well, here's the network. Here are all the ÖBB trains that you can use in Central Europe. So you can compose. Imagine you have a traveler card or discounts or whatever. Oh, let's have a trip on ÖBB. Where can we go? A search engine doesn't show you this because it gives you, as an answer, a list of things. It gives you one-dimensional answer. Here is 2-dimensional answer. Here you have dozens, if not hundreds of answers at a glance. You see them all at the same time. Your brain sees all of this, interprets it, and has an image of all of that, and can then compose and ask the questions. So you have all of Europe at a glance. You had no idea those networks existed. You had no ideas if they connect or not. And if you ask not only the big search engines, but the national ones, you're in Paris, you go to SNCF, it will not tell you about other trains. It will tell you only about SNCF trains and some others, but you will not get most of these. So the map shows you where you can go. It's very detailed. I have here all the operators and the detailed train stations, because also you need to know at which train station you go, if there are several. And it tells you who is the operator, where can you buy the tickets, because otherwise you're lost. So those principles of schematics, well, actually they can be applied to something much bigger, on a scale much wider than just a city or a small network. It's a principle for networks. Now, next stage, the world. Now I have Europe mapped, the US is mapped, and Canada, I have Australia done, and I'm working on India and China, where it's a bit more complicated in India. China is quite straightforward, but it has lots of trains, so you have to choose which ones to show. It's a work in progress. It will exist someday. I built a website for it. It's called night-trains.com, obviously. So you have the map there and the destinations. It's being upgraded now, but it's already quite nice. So that's the ambition. Let's map the whole world. Now, mapping the whole world in rail is something else, but here it's a very small niche, very particular, and people who really want that. I want to sleep in the train. Last project. Well, China. China is big. China has lots of cities. And most of those cities you've never heard about and are bigger than Paris. And while working on the trains in China and other projects related, I just realized that I was ashamed. I couldn't name more than 5, 6 cities in China, and let alone place them on a map. And, well, ashamed as mapper, intellectual. I can name 20 cities in the US. I can name many more in Europe. How cannot I name those places in China? How cannot I place them on a map? What's the problem? Okay, language for one. The names do not sound familiar. Then second thing, you take Europe, you have lots of peninsulas and gulfs, and it's quite easy to identify Spain or Italy and then place something on it. Then you have the Alps cutting into two, so you go north or south of the Alps. China, it's a bit more difficult. You have like one big region, no big mountain range in between, no big peninsulas showing you where you are, and everything is concentrated there. So what can you use, what tool can you use to know more or less where those cities are located? Well, while working on the networks inside China, you realize that the main trunk road, north-south from Beijing to Guangzhou and Hong Kong, goes through Wuhan, and the main east-west one from Shanghai to Chengdu goes through Wuhan. That's the crossroads of China. And well, the distances are pretty similar. From Beijing to the center, from Wuhan to the south, it's more or less the same. East-west, a bit different, but quite similar. So there is like a basic structure that you could use by using several of those cities, like the stars in the night sky. You see just the points, and then you have imaginary lines connecting them so that you can go from one to the other and locate it. Now for the landscape, that central part of China, well, the coast is more or less half a circle. Not perfect, of course, but I allow myself to distort the geography a little bit in schematics. And then you have the Vietnam, Indo-Chinese peninsula in the south, Korean in the north, and a ring of islands Hainan, Taiwan, and then Japan. That's more or less how it works. So can we convert all of this into a diagram so that you can have a mental image of the structure of China and then be able to locate the cities and be able to draw the map? So how do we do it? One vertical line, one horizontal line. We get a cross with, well, that's north-south, that's the coordinates. Now if you link the extremities of the cross, you get a square on its tip. On that square, you have those 5 main cities. Beijing is on top, Hong Kong down, Shanghai, Chengdu, Wuhan in the center. Now you draw a circle around that square. The eastern part of the circle will give you the eastern coast of China. You draw a second circle, twice as big. In between those 2 circles, you will have one peninsula for Korea, another one for Vietnam. And now we just have to add the islands, and we have a nice yin-yang style schematic representation of China. Now when you have this in your mind, it's not a geographic representation, the distances are not perfect, but you get an idea where things are so that you can connect them, you know more or less the distances, and with that basic diagram, you can go and build on and put all the others. Now I'm not going into details, but you go midway from Wuhan to Beijing, you draw horizontal, where you encounter the square, you get Xi'an. Where you encounter the vertical, it's Chengzhou. And then you can place some 30 Chinese cities on that diagram. But the basic is this. It's a structure, the symbolic structure that represents the whole, and that is holding everything together, that is helping you memorize, and that is actually shaping your perception, be it of a metro network or of a whole country. I bet that next time when you look at the China map of China, well, you will see this. Now that you've seen it once, you see that circle and that square all the time. So now I'm just shaping your perception of something. That's the power of the maps and even more of schematic maps. Reality exists, but when I give you a representation of that reality, I'm altering how you perceive that reality. It's a tremendous power, what I was saying at the beginning of this symposium. It's an absolutely tremendous power. Most people do not realize how much maps shape our perception of things. And most of maps, nobody knows who makes them, why, how. There is no neutral map. We choose what we place on the map. We choose what we don't place on the map. We choose how we represent things. So we are shaping those minds. We have a tremendous power. We have an enormous responsibility. So if we didn't have the responsibility, we would be like gods. We are creating reality. Well, we have responsibility. Let's say we are demigods, and let's enjoy it. Thank you.
Do we have any questions for Jug? Quiet crowd today. Oh, there's one.
Who knows more than 5 cities in China? This will become a book in a month or so, this whole China story. It's being translated in Chinese as we speak.
Hi, on the city level, what's the hardest city that you had to map?
You mean the metro maps?
Yeah.
Well, Tokyo was the most difficult one because you have so much information to place on it. It was very difficult. Then another one that was difficult was Chicago because it has a very, very strict grid of streets. So when you're trying to find that balance between the schematization and distortion and connection with reality, it's very difficult to blend those because New York lets you distort the grid, but Chicago doesn't. It's squares. So you just can't distort it. You see immediately there's a distortion. So in that sense, Chicago was difficult, even though it has a perfect grid. But Tokyo definitely.
And what was the easiest?
Xi'an was this. 2 lines. It's perfect cross. But sometimes small networks can get very tricky. Cyan is easy because it's really Cardo de Cumanus, but some small networks, because you don't have enough information. So you have your layout and you cannot fill it. Or only one part of the city has metro and the other has little, and you have a disbalance in your map. So you have to find ways to fill the map or to distort to make it look nicer.
Yeah, you can regale me, or you can come and ask me later how the arguments we had about his Montreal map and how he distorted the Montreal geography.
Thank you. My question is also relating to those mental maps. Are they both received very well among locals and tourists? Because those are two very different target groups.
Well, I have feedback from people who use the app and people who send me emails. Have people from almost all those cities that I mapped sending me emails whenever there's a new station, there's a new line or something, so that I can update it. And so far, nobody has complained about the way I represented it. And everybody's quite happy. Now, maybe people who don't like it just don't write. I don't know.
Oh. Gonna cut across here, thank you.
Hello. Thank you very much for your presentation. This is really impressive, and honestly, I'm a large fan of your Luxembourg map. I think that's great, and I'm going to be mentioning this in my presentation tomorrow afternoon. My question is, this goes a little bit more into wayfinding, but there has been a lot of buzz around the fact that we are, especially when we are dealing with the wayfinding, normally what we do with maps, we design our maps north-oriented so that the north is always on the top. But when we were dealing with the wayfinding, for instance, we've had this large wayfinding debate in Moscow about whether we should be for our street wayfinding, the city wayfinding, whether we should be turning the maps around depending on from where you're standing and from where you're looking onto the surroundings, or we should not rotate them. I think there's no single opinion that could be right on this question, and maybe it depends. But my question would be as follows. What do you think about this phenomenon in general? And you were talking about the power of representation, of schematic representation onto our perception of reality. So do you think this is a phenomenon of the similar kind, and how, in your understanding, this impacts the way we perceive our cities? Why does it impact some people, in your understanding, the fact whether the map is north-oriented or not north-oriented? Thank you.
Well, I had those discussions and experience. So I have two anecdotes, let's say. First of all people are different, right? So you cannot please everybody. It's impossible. So you need a common coding, common representation, but you need people to adhere to it, to accept it, because for some it will be fantastic, for others they cannot use it. We had the situation in Belgrade when we made the new wayfinding system, where we had the totems with local map, like 5 minutes walk, and then the city map, so you can know where you are in the city itself, which represented like 15-20 minutes walk. And the debate was, should we turn the map towards the direction you're facing, or having north top? In that case, it was solved quite easily, because turning it to your direction made us turn the whole city. Now, when you turn the whole city, it doesn't feel right. If you have La Seine or the Thames totally turned, you don't recognize the shape you are used to seeing. So in that case, we stick to north top. Now I encountered another situation, is if you decide, okay, we will turn the map towards the direction the user is facing, so that he doesn't care about north, right? You're underground, for example, you don't care where north is, You just care where you're going. Well, if your map is placed on a flat table or lightly slanted, no problem, you see the directions. But if you put it on a vertical panel, well, some people consider that forward is top, some people consider forward is down. So how do you orientate it? And I've seen both. So it's a tricky question. You don't know how people will react. Most will consider that top is forward, but not all. So you should put it on a slanted panel. Okay, then no problem. You have the direction, that's it. But on vertical, it's very tricky. So I have no definite answer. I prefer north top as a convention because it's an old convention and we all know how it works. So you see a map, automatically consider it's north top. Now, that requires teaching people how to use a map because some people cannot. Seeing the map north top, they cannot relate to their environment. It requires practice. So no definite answer, but yeah, it's an open debate.
And if I may ask just one addition to that, do you think this phenomenon of north-orientedness has any impact on our urban planning, like on what we do with our transport networks and how we expand them and how we plan our cities? What is your opinion on that?
Maybe it can have, just like you don't want to be called North Dakota because it sounds snowy and cold, like the island of Corsica was cut into two departments. One is southern Corsica and the other is upper Corsica, not northern, because you can have northern in the middle of the Mediterranean. So yes, that north-south perception has psychological impact, let's say, and probably some bias in planning. Now I think that it does not influence that much as other things. You let me do a metro map for a city. If you let me change the colors of the lines and schematize them as I do, I can change the ridership. If I change a line that is meandering yellow into straight red, I'll double your ridership at least, and I will change the real estate price around that line. So that's what I'm saying as tremendous power. So I think there are many more things that are much more influential than the orientation.
Thank you.
Anyone else?
Yeah. How much does the need to place text, like especially from the station names, especially inside very city centers? How does this interrupt like the simplicity of maybe the design, or do you consider the amount of text you need to place on the maps before?
I have two things in this. First, I try, and usually I do, to put all the labels horizontal, first of all, because otherwise it's not that legible. It's much better when it's horizontal. Second, in the, let's say, hierarchy of priorities, those layers of reading things, I put lines first. I consider that the lines are the most important thing on the map because that's the network, the structure of the network. Then come the connections, then the stations, and in the end, the labels. You could use the map even without labels by counting stations or whatever. So I would never change the shape of a line in order to accommodate the text. I rather put the text on top of the line, even though I try to avoid it. I have, in Tokyo, it's difficult to avoid. In many maps, I have avoided it altogether. But if I have to choose text or line, line wins and text goes on top with some white outline or something. But it will not, the text cannot be allowed to influence the shape of the network. Because the text you can change tomorrow. The network is there.
So you talked about the integration of your work in the Google application.
Yes.
How do you marry the geographical-based vision of maps with your schematic vision?
Well, we have the Google people here to answer. Are they here? should have answered. You should have asked earlier. As for now, it's just a button toggling the map and showing you. You're on the geographic Google map inside the app, into transit, looking at how to go from a place to another. There's a menu in which you have schematic map. So you can just choose it and the map will pop up. And it's a static map, a JPEG now. It will be developed further. But when I was in Seoul, in Korea with Neva, we made a new map for Seoul. That's why they invited me there. And they have integrated the map into the digital platform, digital navigation platform. So you have direct connections from many points inside the physical map in order to go to the schematic one. And the schematic map is vector-based, animated. You get your routing on it. You get all the information that you need. So
Okay,
I hope in the future something like this will happen in.
Okay, but it's you are still separated. You're not merging the the two.
Now it's two different features. It's just like a goodie that you get. But I have no control over that. I just do the map.
Anyone else? Oh. Back where I started.
Sorry to make you run. When I see all these realizations, I think that there is a clever limit you didn't pass. In Paris, in many cities, the transport authorities and the transport operator have a multimodal vision. So we think that the passengers jump from one mode to another. You have noticed that in my presentation, my first page was a bus map and a metro area map. In the suburbs, I didn't show that, but our maps are multimodal. They show all the networks. In the cases you have shown, you have buses networks like in Luxembourg or Takamatsu, or rail network in Paris and Tokyo. So my question is this a graphic limit which should avoid us to imagine that we should present the networks totally with all the modes? Perhaps there is a cognition limit which must be respected and which must stop us of presenting too dense networks with too many layers. So my question is, if you have not done that, did you respect this limit because you were not able to do that, or you have thought that it was not possible to do that?
Depends on which ones. For the schematic metro maps, I stick to everything that is on rail because it works on different scale than buses. So I didn't want to mix the scales. That's why I don't have buses on metro maps, the schematic ones. In Takamatsu, I have everything. I have and rail and bus. So I've put everything I had. I put everything in. Now, I have been dreaming of a Paris map, such as you have separate metro and bus to have them together. I've always dreamed of seeing that, the physical one, right? Not the schematic one, because you have a huge layout and that might work. I don't know if it would work. So I'm working on it in Madrid. I'm now working on a map of, because the bus map in Madrid now is absolutely useless. So a new bus map that integrates and buses and metro and cercanías, everything on one. It seems to work. It's not finished, so I cannot confirm. Now, there is a limit. It depends, I think, on the network. If you want to put everything on one map in Tokyo, I think it's not a good idea. Because it's not only the quantity of information, it's the scales. If scales match, then you might put everything together. If they are too different, then you're in trouble. In Paris, bus and metro function almost at the same scale, because the distance between stations in the metro is quite short. So it's all pedestrian scale. The lines follow more or less the streets. So that could be combined. In other situations, maybe not. But you're right, there is a cognitive load limit. That's what I'm trying to address with the information hierarchy, in using layers of lecture on the map, so that you don't get all the information at the same time. Now, where's the limit? We have to find it.
I don't have a question, just wanted to make Richard run. I'm joking, of course. The first question would be, what maps do you use when you travel? And do you refer back to your maps as a reference point to guide you around complicated places? The second question is...
First answer, I do use my maps.
Okay. The second question is, coming from a place where we don't have, or we're not used to reading metro maps, I think seeing a unified kind of guideline helps us understand how to read maps and help us explore other cities easier and better. Now my question is, how do we get that to happen? What is the plan to actually realize that? How do we get people to think that way and help us produce that unified worldly guideline of metro maps or transit maps?
Well, that's what the symposium is for. First, to see if it's necessary or not. Should we go into that direction or should we not? Should we have local things, local wayfinding systems that are completely different, or try to find something common? I don't say the same, but some common directions, common guidelines. I think it should be done. Now, today it's something that I'd say it's possible, in the sense that 20 years ago you had the local agency making the maps, and that's it, you have just the official map. But now that you have the big digital platforms as Google and Apple, and guys like me coming from out of nowhere and publishing things, well, we have to go together to put things together, because as I was saying, the official map used to be the only one. Everybody trusts it. That's the image of the city. Now it's not the case. Maybe more people use a Google map than the official one in some places. So which one is the most trustful? It's like in the newspapers world. You used to have newspapers. You buy them, you read them. Now you like it or not, but what is written there, it's written by journalists. They have an ethical code. Well, now anybody can publish anything on the internet. Anybody can have a blog. So you have overwhelming information, and you have to go through it and find out which one not only is the truth, but is at least reliable. So how do you go through it? So you could say that old reference newspapers, as the New York Times or the Economist, are like, what is their function today in that overwhelming sea of information? Well, to be some kind of beacon, some lighthouse that you can refer to and then go to others. Well, that's a bit what we're talking about here. Which one would be the lighthouse? If it's the official one, perfect. How does it relate to the others? So that you don't get lost in translation in between using another app and the official one and not being able to connect. So it's about those connections, finding those common things that we can have so that everything works together.
Anyone else want to see me run? No? Just you, Zach? Yeah. All right, well, thank you very much, Jug.
Thanks.